Good afternoon, students. Let us solve the problems based on the laws of logic, today's class. So the first problem is based on the write down the negation of the following conditional they have mentioned. Let x be a specified number. We don't know what is the value of x. Let it be a specified number. Write down the negation of the following conditional they have mentioned. So here the statement is if x is an integer, then x is a rational number. So let us take this section as p, that is p is nothing but x is an integer. Okay, you know that if p then q is nothing but x is a rational number. Let x be a specified number. Write down the negation of the following conditional. Okay, you need to find the negation of the following conditional. This is just a conditional. We need to find the negation of the following conditional. So you know that p conditional q is based on the formula of the conditional. We had the formula is nothing but negation p or q, but negation of this p conditional q will be nothing but negation of this. So that will be, it is again negation of this itself. So what it will be, negation of p will give this, and then it is, see this side if it is negation, if you apply negation, this side also you apply negation, what it will be, negation according to the De Morgan's law, negation p is nothing but p, and this symbol will be and this will be negation of q. So you know p and negation of q. So they are given a conditional. For that you need to apply a negation and then write down again in form of statement. So you know p, if x is an integer, p is nothing but x is an integer, q is x is a rational number. Therefore, according to the result, what result we required is nothing but this is in terms of p conditional q. The result we require is negation of p conditional q. That is nothing but p and negation of q. So what will be the negation of this is nothing but this particular statement. Negation of this entire thing is nothing but result is p conditional p and negation q. So write it as it is. X, write in this in terms of compound proposition. X is an integer, and negation q is nothing but and x is not a rational number. So x is an integer and x is not a rational number is nothing but the negation of this entire statement. So this is how we are going to solve. I'll repeat. Let x be a specified number. Okay, write down the negation of the following conditional. They are told if x is an integer, then x is a rational number. You should write again in terms of compound proposition. So you know if then is nothing but meaning is nothing but conditional itself. So this if p then q. So that is again we are writing in terms of this statement is in the form of p conditional q. They told you to find the negation of p conditional q. So you know the meaning of negation of whole p conditional q is nothing but p and negation of q. I have solved this over here. You can just refer. So just a normal p conditional q is nothing but logical equivalent to p or negation of q. When you put whole negation, then you will put whole negation over here also. So this is what is required. When you put whole negation over here, you apply De Morgan's law. So sorry, negation of p, this is not there. Negation of p. The formula for p conditional q is negation of p or q. So when you put negation of p conditional q, here it will be negation of p or q. When you apply all negation for this, then it will be what? De Morgan's law. So negation of negation p and negation of q. So you know that negation of negation p is nothing but p and negation q. So this is what you wanted. So that you are written in terms of compound proposition. So that is regarding the example 1. Next is example 2. Again they are told write down the negation of the following condition. Let x be a specified number. So here they have mentioned if x is not a real number, x is not a real number, then it is not, x is not a rational number and not an irrational number. So we'll take p as a real number. Let us take write pqr. Okay. So x is not a real number means it is a negation p, right? So what it should be? If you want to write just p, so it is nothing but x is a real number. Q is what? let us take this as q. Not a rational number means negation of q. So here we'll write as x is a rational number. R means what? Not an irrational number. So x is a irrational number. Okay, so we'll just write p, x is a real number, q, x is a rational number, r, x is a irrational number. Here everywhere it was not. When it is not, it is obviously not p, not q, not r. I just wrote pqr. So I hope you're clear with how to write it. So now just see the statement. If p, then this entire statement, that is p conditional, something within this, and here it is not, so something and, like if p means this is not, right? If negation of p conditional, negation of q and negation of r. So this is in terms of the statement over here. This is what is given. Negation of p means x, if x is not a real number, then it is not a rational number and not an irrational number. So this is how we are going to give the negation p, conditional, negation q, conditional, and negation r. Now for this, let x be a specified number. Write down the negation of the following conditional. So for this entire you should apply the negation. For this entire you should apply the negation. So what it will be? You know the formula. Negation of this conditional, this. Negation of this conditional, this will be in terms of, we'll write over here. What is the formula for negation of something like p conditional q? What is that? What is the formula for this? So it is nothing but p and negation of q. P and negation of q. So this term will take it as p. This term will take it as q. So it is nothing but p negation of p conditional q. So it will be nothing but just p. Right, as it is, just p means it is, in terms of ours it is negation p and negation of q, right? So it is negation, within q we have negation of q and negation of r. So if you want, I'll write it again here. I'll repeat again. See, they have told if x means if x is not a real number, that means if x is not a real number, here p is x is a real number. If x is not a real number means negation of p, then x is not a rational number, something x is not a rational number, that is not a rational number means this, okay, x is not a rational number means that is q. X is not a rational number means negation of q, within that and not an irrational number, so negation of r. This is you take considered as, just consider in terms of, if you want to write in terms of formula, nothing but p conditional q. It is not, this is negation is only for this term, so we cannot apply all negation, so it is p conditional q. Okay, p, this is in terms of p conditional q, but in this he has asked to apply conditional. Write down the negation of this particular expression. So for this all you have to apply negation. So when you apply all negation, what is the formula? This is the formula. So you write p as it is. This is taken as p. So you write as it is p. So that is negation p, and then and of this negation q and negation r, and for this all. So according to De Morgan's law, what is the formula? Negation of p, and when you take De Morgan's law, negation cancels, so it will be q or r. De Morgan's formula, you know, negation, this you take it as cancels, right? This symbol will be replaced and this will go inside, so it will be negation of negation q or negation of negation r. Again by double negation law, this will be q or r, so it will be negation p, and this is what we needed. Now this you should write in terms of compound proposition. So therefore our compound proposition is x is not a real number, x is not a real number, and x is not a rational number, x is not a rational number, x is not a rational number, or x is not a irrational number, irrational number. So this is how we are going to write the conditional for this particular expression. Okay, next we'll solve these example. See, they are told simplify the following compound proposition using the laws of logic. So let us solve the first problem. Okay, the first problem is we are going to solve this problem using the laws of logic. The first one is P or Q and negation of P and Q. This is the problem. P or Q and negation of this, negation P and Q. So this is the first problem. So let us try to solve this particular problem by using the laws of logic. So you know P or Q can be written in terms of, we can write it in same because we cannot further solve. Let us keep this particular thing same. After that, this negation and negation of P and Q, how to solve this particular problem. So here you can see we can apply De Morgan's law because for this entire there is a negation. So we'll just apply De Morgan's law. So what it will be? It will be nothing but negation of P or negation of Q. So this is the result. You should write here how you got this particular thing by De Morgan's law. So you got this by De Morgan's law. P or Q and negation of P or Q, you got this by De Morgan's law. This I wrote as it is. I just solved this entire which had a negation. I just applied De Morgan's law, so this negation goes and this symbol replaces with this or. Now how can we go solve further? Can I solve this? Yes, double negation, I can apply the rule of double negation and I can just make it as P. So this will be again equivalent P or Q, and within this you have P or negation of Q. What law I applied? I applied the law of double negation. You should write this particular statement by which law you got that particular result. So remember, you need to write every statement over here by De Morgan's law, by law of double negation. Such way you need to write over here. Okay, and after that you applied P or Q. Okay, P or Q and okay, no, further how, wait one second, further how can we solve this particular problem? It is in the form of what? P or Q and P or negation Q. So you can see or over here, and over here, or over here. So which law is easier to apply? Which law we can apply over here? It is in which form? This is in P, this is Q, and here you have negation Q. You can take this as R. Let us consider this term as R. So where you get P or Q and P or R? By applying nothing but the distributive law, we get it as, we can write this is nothing but the distributive law. So we get it as P or Q and negation of Q. So which law we applied? By distributive law. We got it by distributive law. We got this particular expression. Now it's easy. You know that Q and negation of Q can be further solved. But what will be the result for this? Which law I can apply and get the result? You know Q and negation, inverse law. Q and negation Q will always give you false not. That is done or with P. So we applied by which law we got F naught? By inverse law. After that, P or F naught is always P. By which law? By identity law. P or F naught is always P by identity law. So students, if you don't know the formula, if you don't know the laws, you are not able to solve this particular problem. So you should know prior the laws before you're going to solve this particular problem. So the question was regarding simplify the following compound proposition using the laws of logic. So we had this particular question and then they told simplify it using the laws of logical. So what I did in the step 1, I couldn't solve this further because it was already in one form. Here somewhere I had one negation, whole negation, and then I had some expression. So I just applied the De Morgan's law. You just need to apply logical thinking. I applied the De Morgan's law. So when I apply De Morgan's law, this negation goes inside and this will become or, and then again this negation applies over here. So I got negation of P or negation of Q, and then I removed this negation. So how can I remove this? By law of double negation. You know that double negation of P is always P. I replace this with this. I replace this with this. Then I got P or Q as it is and P or negation of Q. You can see this is or, this is and, this is something like P or Q and P or R. So you know distributive formula is what? But you just remember the distributive formula. P or Q and R is nothing but that is logical equivalent to P or Q and P or R. That is logical equivalent to P or Q and P or R. But instead of R, you have negation of Q. That's it. You have negation of Q. So I wrote the form of this P or Q and negation of Q. Instead of R, you have negation of Q. So this Q and negation of Q, you know, obviously inverse law. When it is and again, it is always a contradiction. That is F naught. So P or F naught. Again, P or F naught can be solved by using the inverse law. And finally, I got the result as P. So this is how we are going to solve using the laws of logic.
So we had solved the first problem. Next problem is regarding P or Q and negation of P or Q. So let us solve this particular problem, that is using again the same laws of logic. So the question is P or Q and negation of P or Q, and then this bracket close, sorry, in this bracket close, and then it is this one. So this problem again you have to solve based on the laws of logic. So similar to the previous problem what we had solved, just only thing is here it is or, but whether we can solve this particular P or Q, no, it's, let us start solving whether we can resolve P or Q using laws of logic, no. So as it is, you write P or Q, then and this we can solve because we can use the law of De Morgan's law. So it will be negation of P, negation, that means this is entire negation of this thing, and here or is there. So when it is De Morgan's law, what is the De Morgan's law we have? So negation of P or Q will give you negation of P and negation of Q. So this is De Morgan's law. So it will, since it is negation P already it is there, so it becomes negation of P and negation of Q. Okay, so this is by De Morgan's law. You need to write which law you have used. So it is by De Morgan's law. Next again it will be like, write as it is, P or Q, and then here this can be solved again by this can be solved again by P and negation of Q. What? How I solve this section? Again by law of double negation. So you know what is the law of double negation? Double negation of P is always equal to logical equivalent to P. So this is law of double negation. This is law of double negation. So you got P and negation Q. Now just see how can I solve this particular sum. This is P or Q and but here it is P and negation Q. This is, I cannot apply I cannot apply the distributive law. I cannot apply the distributive law. Why I cannot apply the distributive law? Whether the form is in distributive law? No, it is not in the form. In case if it has to be in the form of distributive law, then here it should be in the form of this one. Okay, it is fine. P or Q. You know, in distributive law, it is just write here P or Q and R is logically equivalent to P or Q, and this and will go in between, and P or R. But you can see here this is fine, this is fine, but this symbol is and instead of or, so I cannot apply the law of distributive law. Other than that, what concept I can use to that to do the changes? So any other law we can apply? No. So what you can see over here is take entire this section as P and let this be and let this be P some other term and negation of Q. Let it be this something like it's not same. Okay, just I'm just taking an example. So here you can see and, here you can see and, here you can see and. 1 minute. So you can, here you can see and, here also you can see and. So what you can do is you can use which law. So we can apply which law over there. You can apply which law over there. So right, just to this you just assume it as P, one term you assume, and this you take separate, this is separate, this is separate. So can I change the, so can I change erase now this section. So can I change the bracket over here? I'll tell you what, write P as it is, P or Q. This will be as it is, P or Q. Okay, and I just change the bracket. Why? I'll tell you. This is P or Q and P and negation of Q. If this and this is same, this I took one term. You know what is commutative law? What is commutative law? Sorry, what is associative law? What is the concept of associative law? If P and Q and R, then you can just changing the bracket P and Q and R. Same thing I applied here. Instead of P, in our question we have P or Q. Then instead of this P we have Q. Instead of this negation Q we have R. So I use this particular law, and I change the bracket. That's it. I put the bracket over here. So it is P or Q and P and negation of Q. So that will be, so that will be this way. So it is again by which law? It is again by associative law. So you need to write which law you have applied by associative law. Again over here, I want to place that term over here, in the sense negation of Q, let it be over here itself. Okay, I mean I want to place this P this side and P or Q this side. So what you have to do? That is nothing but which law we are using? Commutative law. So P and P or Q and negation of Q. So you know what is commutative law? By commutative law, I wrote just in shortcut CL. You need to write in full form commutative law, by commutative law. So what is commutative law? P and Q, if it is there, commutative law is nothing but Q and P. Just writing, interchanging the terms. So here this is, take it as P, this you take it as Q. So I'll put Q first, this next, and this symbol as it is I wrote here. So it will be P and P or Q and negation of Q by commutative law. I hope it's clear. Now you know this P and P or Q. P and P or Q is what? P and P or Q is nothing but P. you know the absorption law. P and P or Q is nothing but the P and this you write, and negation of Q by absorption law. By absorption law. By absorption law. Okay, so this is how you're going to solve this particular problem. I'll repeat again. P or Q and negation entire to this. So what I did is I cannot solve this further, and here this negation I applied for this. So entire for this I need to apply. So you know negation is there and in between or is there. Take these single as a single term. So again I apply De Morgan's law. So when I apply De Morgan's law, it will be formalized negation P and negation Q. So it is nothing but negation of P and negation of Q. So this will solve to just P, right, as it is P and negation Q. Next, what is there? I cannot, this is not in the form of distributive law. So I just took this as one term, and here and is there, here and is there. I combined these two terms. I combined this term and this term within the bracket. And then again I applied commutative law. Interchange, then by absorption law I got P and negation Q. So this is how it works with the example 2. Last one is example 3. Example 3 is negation of whole negation P or Q, negation of whole negation P or Q and R, or negation of Q. So let us solve this particular problem. Okay, so the third one is regarding question is negation P or Q and R, flower bracket, and negation of Q. Okay, so this is the question we have. So how can we solve this? Can we try to see over here? It has negation for this, whole negation for this, then again outer it has whole negation for this. So how can we solve this? See over here. So this will be logical equivalent. This has negation for entire term. So negation and this or is there. Try to solve this. What law we can use? We can use De Morgan's law. So when I use De Morgan's law, this will be negation of this term. So again it will be negation. This negation as it is you need to write P or Q and R, double negation, and it's De Morgan's. Whole law means what will happen? This negation, this term, this negation is already there. So I wrote as it is negation this term, and then this symbol will be and again negation is already there. According to De Morgan's, another negation should come. So it will be double negation of Q. So you need to write by De Morgan's law. Next, what will happen? I can cancel this or the double negation, right? Whole double negation. So you can cancel. So it will be P or Q and R and Q. P or Q and R and Q. So which law again? By law of double negation. By law of double negation. Then now what is the next step? So you see over here, this is a single term. You can consider a single term. So which law we had used for this? This is a single term. Okay, Okay, this is a single term. We have an R and here. Even if you don't consider it as a single term, can you solve further? No. So I have to use the associative law and put a bracket over there. So first, before I put associative law, I need to do the I need to apply the commutative law. Before I put associative law, I need to put the commutative law. So we'll write as it is. P or Q I wrote as it is. And here I apply the commutative law. You'll come to know why I applied the commutative law. So I'll just write Q and R. Then I'll tell by commutative law. Then here why I applied commutative law, I'll just put the bracket over here. That is the one intention. This single term I took. So I'll put as P or Q and R. Okay, P or Q and R. I applied a bracket, but now this, I applied a bracket. Let this bracket be as it is. Okay, I applied a bracket over there. I just put a bracket. By which law? I just put a bracket by associative law. I can apply a bracket, right? There is no issue in applying a bracket by associative law. After that, this will be P or Q. I just need to interchange again Q and here also I need to interchange Q or P. So I applied actually twice commutative law. I made Q this side. You can reduce that step into one itself. Q this side, and here also I interchange. If you get confused, I'll do it step by step. Wait. First we'll interchange this, because I'll tell which form I want. That form I'm interchanging. So I made Q or P, and Q let it be as it is. Here within this I applied commutative law, and R by, I'll just write C here, okay, commutative law. Now again I applied commutative law, so that means Q will be here and this will be Q or P and R. So what is this again? Q and Q or P. You know that by absorption law, this will get reduced to again just Q and R. So you write here by absorption law. So again, that's what here directly you can write apply twice commutative law and interchange. Why? The main intention was I want it in this form. Okay, so this is regarding the third problem. Next, let us go to the example 4. Simplify the following compound proposition using the laws of logic. Simplify the compound propositions using laws of logic. So let us solve the first one. First one is P or P and P or Q by conditional P. P or P and P or Q by conditional P. Okay, so just see over here itself. Write P as it is. What is this in the form of? It is again in the form of, if you what is the question is, they told that prove that solve this left hand side and get the answer of right hand side. You need to get the answer of right hand side by using the concept of laws of logic. So P or P and P or Q. So let us solve the left hand side. I'll take the left hand side separately. Wait one second. P and P or Q. So this is a left hand side. Write P as it is because we cannot solve further. But if you solve this, you'll get it as P. Why P? You know that P and P or Q will always give you P by which law? By absorption law. So that's what, students, you need to remember you need to write down 5 or 6 times laws, then only you'll get to know, or you need to hold a sheet of laws while solving this problem, otherwise it's not so easy. So P or P. So P or P, I can write it again as just P. P or P, I can write it again as just P. Which law? It is again by idempotent law. Idempotent law. So this is very simple. And finally I got P, which is what I wanted over here. So I'll repeat, just I applied two things, P or P and P or Q. I wrote as it is over here. This is of the form of absorption law. You know, in absorption law, P and P or Q is always logically equivalent to P, or if you have P or P and Q also, it is always logically equivalent to P. So I wrote this as P. Idempotent law is nothing but P or P is always P, P and P is also always P. So this is the concept of idempotent law. So if this form is there, you can write directly P by using the idempotent law. Okay, so next problem is regarding P or Q. So let us solve this particular problem. P or Q. Next problem is regarding, that is P or Q or negation P and negation Q and R, close the angular bracket, is logically equivalent to P or Q or R. So you need to solve this particular section and you need to prove P or Q or R. Answer is P or Q or R. So what will we do is we'll solve this first section. I'll just take this particular section and I'll solve this particular section. Then we'll see what will happen. Okay, so there is P or Q, right as it is. I cannot solve this further. Here I need to solve this particular section. So it is negation of question is negation of P and negation of Q and R. So it will be P or Q, or here can I put a bracket for this, that is negation of P and negation of Q and R. By which law? By we applied by associative law. By associative law, I just wrote associative. Can I write P or Q or negation of P or Q? P or Q or negation of P or Q. What is this? This is in the form of De Morgan's law. That is nothing but negation of P or Q will always give you negation of P and Q. Which law I applied? By De Morgan's law. By De Morgan's law. So you know that P or Q or negation of P or Q. Okay, or negation of P or Q. What is this form of? Whether it is in the form of inverse law. So you know that or it is in the form of inverse law. If not, how can you write it in this sense? It is in the form of inverse law. P or negation of P or negation of P or Q or R. So you can write it in the form of inverse law. Okay, so here it is in the form of inverse law. If not that, other way we can write it, other way we can also solve it in the form of by distributive law also. So before we, wait, I'll just tell you over here, wait, sorry, 1 second. Here we had written negation of P and negation of P, we applied De Morgan's law, so it became negation of P or entire negation of P or Q and R. Okay, sorry, entire negation of P. I did a mistake. I just told you to apply. Okay, we'll write as it is. So this is in the form of De Morgan's law. So it will be P or Q and R. So this is what we will get P or Q and P or Q and R, we got it. So if I want to solve this particular section, which way I can solve this? So this is one part. Okay, this is one part. I want to solve this particular section. How can I solve this? So here you take this term as P, let R be there, this term as Q, and this as R, this term as Q, entire thing. So how can I solve this particular section? Because I want P or Q or R, I want this particular result. How can you solve it? Can I apply the distributive law? Yes. So if I want to apply distributive law, what it will be? P or Q. Okay, P or Q. That means what? This P as it is I wrote. P or Q or negation of P or Q and P or Q or R. So this is one form. P or Q or R. Okay, you might get confused. So let us first write. Here I write by De Morgan's law. Now this further I solved by distributive law. So we'll just write what is distributive law first. You know, in distributive law, P or Q and R is always P or Q. That is logically going to P or Q and P or R. So this is the formula. Same concept I applied. You can see this and this symbol over here. This and this symbol over here. Instead of P, we have P or Q. Instead of Q, we have negation P or Q. Negation P or Q. Okay, instead of P or Q, we wrote P. Instead of Q, we have negation P or Q. Same way I did. This P or this. So I wrote this P or Q or this, and this P or R. In between we placed and. So you know when it comes for P or, so that is again by which law? By distributive law. Write it as it is, by distributive law. So this law we applied over here. After that, you know, P or Q or negation of P or Q. That is nothing but, what is this? Inverse. If this is P, inverse of this, or is always true not. And P or Q or R, that is by inverse law. After that, true not and this will always give you P or Q or R. True not or this will always give you P or Q or R. By which law? First you need to apply actually commutative law, that is changing the bracket. I just did directly over here by commutative law, and the actual law we use to do this is nothing but identity law and identity law. So this is the answer required, and that's what we got over here. So this is regarding the second question of the second part. Next is regarding example 5. Prove the following logical equivalence. So let us solve the first one. The first one is regarding P or Q and P or negation of Q. P or Q and P or negation of Q or Q. So that is nothing but P or, this we have to prove it as P or Q. Okay, this we have to prove it as P or Q. So just see over here. This is of the form what? Just check over here. I'll try to solve here itself. Check this P or Q and P or negation of Q. This is actually in the form of what? It is, can I apply distributive law? If I apply distributive law, what it will be? P or Q and negation of Q. P or Q and negation of Q. So this is what I'll get if I apply distributive law, or Q as it is you write. So this is by distributive law. This is by distributive law. So again here it will be P or q and negation of q. Can I solve this? Q and negation of q will give you what? You know what it gives, p or f naught. Q and negation of q, according to inverse law, p and negation of p will always give you f naught. So write as it is with this. So this is by inverse law, After that, p or f naught, you can get it as p itself by identity law. So it will be p or q by identity law. So that is what is the required result. You got it over here. I'll repeat if you want. This one section and this one section, in between one or. So you know distributive law is nothing but of p or q and r is nothing but, I'm just writing the formula so that you need to do that, p or q and p or r. So same, compare the formula, p or q, instead of r we have negation q, p or r. So I wrote p or q and negation of q. You know this, we can apply inverse law. We know that p and negation of p will always give f naught. So that's what I applied inverse law. But you know p or f naught is always p by identity law. So I got p or q. So this is how we are going to solve the first problem in this particular section. Okay, the second problem is p conditional q. Let us solve that particular problem. p conditional q bracket and negation of q and r negation of q and r then it is or negation of q and then this section, then it is equal to negation of q or p. So this is what we got. This is what we are getting, p conditional q and negation q and r or negation q, negation of q or p. So let us solve this particular section. Okay, so we'll take this left hand side. So which way we can solve this particular problem, we'll see. So you know, you try to see this particular thing, can we solve this negation q and r or negation of q. So this we can write it in terms of what? This we can write it in terms of, we'll try to write here, p conditional q and let this be like this itself, negation q, and we can write this as negation or r. By which law? By which law? This bracket is not there. Okay, the last bracket is not there. By which law? I just change the, interchange the terms, nothing but by commutative law. By commutative law, we change the interchange the terms by commutative law. You just write it, and I wrote it. It's not, I cannot write so clearly. So by commutative law. After that, p conditional q as it is. Can I solve this further? Negation q and negation q or r. You know what it is. It is again negation q. By which law? By absorption law. By absorption law. By absorption law. P conditional q and p conditional q and negation q by absorption law. Now you know that what is the formula of conditional, I mean what is the formula for p conditional q and negation of q? This is of what? This formula is actually of what? What is p conditional q? I'll just write here. Okay, what is p conditional q? You know p conditional q is nothing but negation p or q, and what is p negation of whole? So negation of all this. So you know that negation of negation P, that will be just P, and negation of Q. Again you apply De Morgan's law for this. When you put negation for this, it will be P and negation. So these are the two formulas of conditionals. You need to remember the two formulas of conditional. Now just check here, and negation Q is there, and negation Q is there. So this you take it as P. So P and negation Q. So this entire thing is of the form what? Negation of P conditional Q, conditional Q. You might have a doubt why I did such a way, because I want the output as in terms of negation. That's why I wanted one negation, so I can apply over here itself. So P conditional Q as it is I wrote, and negation of Q. This and this is nothing but formula. So negation of P conditional Q, that is the formula I'm going to use. So which law I applied now? By law of, you can write the formula itself. You can write, or you can tell by law of negation of conditional. By negation of conditional. Okay. So I hope it's clear. I'll repeat. This I solved using absorption. P conditional Q and negation of Q was there. So you know, and negation of Q means it is, this P means this I have taken as entire thing as P. So the formula, this is equivalent to this. So I brought formula will be what? Instead of this, we'll have a conditional, and all will get one negation. So that is regarding this particular problem. Now further, how can I solve this? Particular problem? Can I apply De Morgan's law within over here? Can I apply, or else we'll just solve this? Negation is needed for us, so we'll just try to solve this particular section. That is, this will try to solve just conditional. This negation let it be, don't worry, because we need it. Now inside conditional, this conditional will try to solve. So just it is P conditional Q. So what it is? It will be negation of P or Q. Negation of P or Q. That is by which law? By P conditional Q is equal to negation of P or Q. By this law. P conditional Q, that is equal to negation P or Q. So you got this term. Now how can we solve this particular? Again we'll try to solve this negation of this P conditional law. So keep as it is. This is negation now, so it will be P and negation Q or Q. P and negation Q or Q. So this is one section. P and negation Q or Q. Again by which law? By negation of conditional. So you write in terms negation of conditional. Next you see P and negation of Q or Q is there. Next, if I want to do the changes, how can I do? I need the terms Q or P. So I need the terms Q or P. You might think that the Q or P, I need the terms Q or P in the result. So I just need to apply which law? Commutative law, because Q I want this side, P I want that side. So apply negation here itself. Q, or I did P is this section, right? So write as it is, P and negation of Q. So which law? By commutative law. Next, can I, here it is or, here it is and, can I apply distributive law within? So this you keep as it is. So here it will be Q or P. If I apply distributive law, Q or P and Q or negation of Q. Q or negation of Q. By which law? By distributive law. Okay, after this step, I'll repeat if you want. Here with first I tried to solve this particular condition. Once I tried that condition, that I took P conditional Q. So you know that P conditional Q is nothing but negation of P or Q. Once I solved that particular line, then I tried to solve this conditional. So I got this particular result, P and negation Q or Q. But in the output I want negation. I got negation here. And Q I want first. So I applied commutative law, Q or P and negation Q. Now I applied distributive law. So I'll get Q or P. So I got my answer section over here. But I need to eliminate this particular term now. So you know that Q or negation P is what? Q or negation P is, I'll write the continuation section over here. Negation whole of Q or P, and what is Q or negation of Q? Inverse law. What it is? It is tautology. So again, which law we applied? Inverse law. Right here, inverse law, by inverse law. After that, you know that negation as it is, Q or P and true not will give you what? Q or P and true not will give you P itself. So which law is that? It is nothing but identity law. So this will be Q or P by identity law. By identity law. So if you want to solve these problems, you should know the laws. Otherwise, it's not able to solve the problems by identity law. So this is regarding the identity law. Okay, next let us solve the example 6. Example 6, that is prove the following. So we'll insert this. First one is P conditional Q conditional R, P conditional Q conditional R, that is logically equivalent to P and Q conditional R. P conditional Q conditional R, it is logically equal to P and Q conditional R. So we'll write left hand side as it is, P conditional Q conditional R. So while solving, try to solve always within, inside the and outside the bracket. First you can try inside the bracket, then you can try to solve the outside the bracket. So we'll try to solve the left hand side we should solve and get right hand side as this. So you know the conditional formula of P conditional Q formula is what is the formula for P conditional Q? Nothing but negation of P or Q. That's it. We are using this formula itself. So P conditional, here Q conditional R is there, so it is negation of Q or R. Negation of Q or R, same thing. This formula you apply. Next apply for this negation of Q or R. Next P conditional Q. This is Q now. What it will be? Negation of P. Sorry, yeah, negation of P or negation of Q or R. This is what we will get. Negation of Q or R. Now R, I want in terms of what? P and Q conditional R. So you just see how can I make P and Q conditional R. So here P and Q should be together, you got to know. So what law I can apply? By which law I can change the bracket? I mean brackets. That is nothing but associative law. So here you have or here you have R. So you can put P or negation of Q as one bracket, then write or R. Okay, I did not, this is all using this itself. Okay, by conditional law, you just apply by conditional law here, by conditional law, here also by conditional law, but here I used by associative law. I just change the bracket. Now you know I can apply De Morgan's law. What is De Morgan's law? Negation here it will be, and then it will be P and Q, then it is R. So this is by De Morgan's law. So I need to insert a condition. Now here it is there. Now again, whether this is in the form of this formula, yes, here it is negate. Instead of for P we have P and Q, so you write as it is, P and Q conditional R, or is here or R, P and Q conditional R. So this is how you are going to solve the first problem. Next is regarding second. Let us solve the second problem, that is insert a page. So the second problem is, question is negation of P and negation of Q and R, negation of Q and R, this Q and R, P and R conditionally equal to R. You have to prove that is equal to R. Okay, so negation P and negation of Q and R, or Q and R or P and R, we have to prove it that is equal to R. So over here, okay, can we solve this particular problem? Over here we can negation P and negation of Q and R. Here we have Q and R or P and R. Q and R or P and R. So can we write it in the terms of R and here can we write we'll try to solve this. Here we can change the bracket, negation P and negation Q, we'll put the bracket over here. I'm solving this, and R I wrote negation P and negation Q and R I wrote. Here I'll write as it is, we'll write as it is Q and R, because I'll solve it in step by step P and R. Okay, I wrote as it is. Here this will be what actually, negation P and negation, this will be in the form of it is in the form of negation of P or Q, negation of P or Q, negation of P or Q and R. Here I applied bracket changing law. So which is the bracket changing law? Associative law, right? For this I applied associative. I just put a bracket over here instead of here. So I applied AL. I just write AL. Here I applied De Morgan's law. De Morgan's law. So I applied De Morgan's law over here. Next, what can I do further? I'll keep this as it is, that is negation of P or Q, and R I'll keep as it is, this R also as it is. This is in the form of distributive law. So before that you just apply R and Q or R and P, right? Because you need to apply commutative law before you do. So I just wrote it in that. Both I applied R and Q, R and P, R and Q, R and P, R and Q and R and P. So that I applied using commutative law. Then you write negation of P, or same way you write it, and R. This I can write it in the terms of what? Again, distributive law, right? This is in the form of distributive law, that is R and Q or P or Q or Q or P. I'll write it as P or Q. Again, you can apply, you can tell your by distributive law as well as by distributive law and commutative law. By distributive law and commutative law. Here also you have to change in terms of I need to rotate this. Okay, again by terms of what? R and negation of P or Q. I'll tell why I'm doing that. R and negation of P or Q, or R and P or Q, R and P or Q. Okay, this when you see, you can see that again this is in the form of distributive law. Am I right? Because you can see R and negation of Q, or R and this section, entirely this section. So what it will be actually, it's nothing but R and this I applied again distributive law. What is our distributive law? We have P over here. We have P and Q, or P and some other term R. So it is nothing but what? It is in the form of distributive law. So we'll write the distributive law over here. So the distributive law is what exactly? R and negation of P is there. R and negation of P is there. In between R is there. R and negation. So you can write, we need to write R as it is. Then and then negation of P or Q. Then or P or Q. P or Q. So you know that this is inverse law. This we got it as by distributive law, but this concept is by inverse law. So you know that in inverse between P or negation of P is always inverse law. P or negation P is always true not. So R and T not, you got, that is by inverse law. By inverse law, but by identity law you can get it just as R, by identity law. So this is how we are going to solve. This is how we are going to solve by identity law. Next, The last example is regarding prove that this particular compound proposition is a tautology. Now let us solve this particular problem. Okay, now let us solve this particular problem. That is, insert a new page. So we'll write down the question. The question is P or Q, bracket close open, P or Q, and negation of P and negation of Q or negation of R. Where is this way? Negation of R. Close this particular bracket and then open the flower bracket and again test, or negation of P and negation of Q or negation of P and negation of R. This entire expression, we need to prove that this is a tautology. Now what will you do is, let us take this till here as U, okay, and let the OR symbol be there. This you consider it as V. So we'll solve first set and we'll try what we'll get. This is OR, okay, this is OR operator, this is V. Let us take this as U and this as V. So we'll solve U section. So U section is nothing but P or Q. I'll write here P or Q, okay, and negation of negation P and negation Q and negation R. Sorry, this is square, but this was square. Okay, we'll remove this bracket. So this was a problem, okay, this was a problem. So this was negation, sorry, this was negation. So you know that this can be solved by using what again? De Morgan's law. This will keep as it is, P or Q as it is, and this we can apply again De Morgan's law. What will be the De Morgan's law? Negation of P and negation of Q or negation of R. Okay, you can put a bracket over here again if you want. Okay, so P or Q, and here I put De Morgan's law. Negation was outside and this, so it will be negation P, negation of this entire next term. So this will be P, and again you apply De Morgan's law over here. What it will? Negation of R. So it will be negation gets cancelled. So it will be actually, according to De Morgan's law, it will be Q and R. So this is what you will get. P or Q and, sorry, here I did not change the operator over here. This operator should be OR, right? We did not change the operator. That is, when I applied De Morgan's law, negation of P, this symbol will change to OR. This will be as it is. This is something you assume it is Q. So I wrote as it is, but negation should be there. So here negation of this OR will be replaced by and this negation gets cancelled, and this will be OR. So we got P or Q and P or Q and R. Okay, we got P or Q and R. Now how can we solve this particular problem? So you can see here, this is again, we can apply the concept of distributive. P or Q and P or something. So it is nothing but P or Q and Q and R. I applied distributive law. So here I applied distributive law. So it's easy. See, P or Q, P or some R, P or R. So you know that P, R, Q and R. P, R, this you take it as Q, this you take it as R. So you know P or Q and P or R. So it will be what? P, R. It will be P or Q and R in case if it was. So instead of R we have Q and R, Q and R. So it is Q and R. After that you can change the bracket. You can change the bracket. So if we change the bracket, what it will be? Q and Q will give you P or. You can change the bracket within here. Q and Q will give you and R, you can write. Q and Q will always give you Q itself. It's all capital P, okay? I just wrote by mistake small. So P or Q and Q is nothing but, you know, what is that law? Q and idempotent law. Idempotent law means Q and Q will give you Q and R. Write it capital itself. It was all capital, so write capital itself. Okay, so you got P or Q and R. This is what you got it as U. Now let us solve for V in somewhere. I'll erase this section and I'll solve here itself. Okay, let us solve V in this section. So V is nothing but, this is what I got it as U. V is nothing but negation of P or negation. V is negation of P, negation of P and negation of, one second, V is nothing but negation of P and negation of Q or negation of P and negation of R. Okay, so this is V. So let us try to solve this V. So V is, I can apply De Morgan's law both the sides. So it will be negation of P or Q, De Morgan's law applied, or negation of P or R. Negation of P or Q or negation of P or R. So this will be negation of P or R. So this again I can apply De Morgan's law. So take this negation out. I can write it as P or Q and P or R. I applied again De Morgan's law. Let the negation be out here. So you know P or Q and P or R. By using distributive law, I can write it as P or Q and R. P or Q and R. So same here, P or Q and R. I wrote it here. So I got this way. But you can see it is nothing but meaning is nothing but negation of U. You got it as U, you got it as P or Q and R. V is nothing but negation of U. Negation of U. So what is this? Finally, I want this entire thing as a tautology. So let us take W. W is nothing but U, entire expression. U logical operator V. U logical operator, or I'll write here. W is nothing but, W is entire expression. W is entire expression. That is this section. U logical operator or V. So it is U or logical operator or and V. Okay. And V. V will use small letter also. Otherwise you will get confused. Or V. So this is actually equal to what? U or negation of U. So this you have to prove whether it is a tautology. Yes, this is a tautology. Based on what law? Inverse law. U or negation always gives you tautology by inverse law. So this is how you are going to prove. If you want, I'll just repeat. I took this section as U and this section as V. I tried to solve this section U. So here I wrote as it is. Then I applied De Morgan's law for this. When I apply De Morgan's law, this will be double negation of P. Double negation of P, and this operator will change to or, and again here it will get a negation. So I wrote it over here. That double negation will be P, or will be this. For this again I applied De Morgan's law. So it will be Q and R. So you know you got P or Q and R. So here you got P or Q and P or Q and R. So we wrote it as in terms of distributive law. in terms of distributive law. So you know what is distributive law? This form is of like this. Okay, this is in the form of P or Q and P or R. So you wrote as it is P or Q and R. Then you know by identity law you know that Q and Q is just Q. So I got this particular expression. Next I solved the V section, that is negation. Both places I applied De Morgan's law, and then this negation came out, and this is in the form of distributive law. So I got negation of this section. This section is nothing but our U itself. So I wrote negation of U. Finally I combined both using logical operator OR, and then U and negation of U, you got tautology by inverse law. So this is regarding based on the problems on laws of logic. So if you don't know the laws, then you cannot solve these problems. So while solving the problems, you should apply the laws and then solve the problem. So you should know the laws of logic problems correctly. Thank you. This is the problems regarding the laws of logic.